Hey guys, so we're starting the day 5 video. Today is going to be a short video because the quiz that you're doing today is going to be on the entire lesson on ionic bonding and compounds. So before starting the quiz, watch videos 2, 3, 4, and 5 or just review the PowerPoint. Remember, you don't have to watch video 1 because video 1 was just, or day 1 was just a revision of covalent compounds, so it has nothing to do with your quiz today. All right, so before starting your quiz, we got to get through this. Polyatomic ions. So far, throughout this lesson, we've only been talking about monoatomic ions. A monoatomic ion is like sodium, chlorine, things that are just one atom. So for example, sodium loses one electron and becomes positive 1. Chlorine gains 1 electron and becomes negative 1. Magnesium loses 2 and becomes positive 2. You know what I mean. One atom losing electrons or gaining them to become positive or negative. So today we're going to talk about polyatomic ions. Polyatomic ions are a group of atoms that are put together through covalent bonding, but their overall charge is not neutral. So if I look at this example, ammonium. Ammonium is a polyatomic ion because its charges are not balanced, so it has this positive 1 charge right here. The reason this happens is because if you look at ammonium and you count up their atomic numbers, the atomic number of nitrogen is 7, while the atomic number of hydrogens are each 1, so overall you have positive charges of 11 inside of ammonium. But if you count up the number of the actual number of electrons in this compound, you'll only have 10. Now, I'm not going to expect you to know how to do this, but the basic idea here is that you see that there are 8 here and that there are 2 little invisible ones in the inner shell of the nitrogen. But overall, we have 10 electrons and 11 protons. So the overall charge of the whole compound, even though it's covalently bonded to each other, is a positive charge because there's an imbalance between the protons and the electrons. This happens a lot. This is not the only example of a polyatomic ion. So if you look over here at nitrate, nitrate is also a polyatomic ion. You could see right here that the nitrogen has 4 bonds between it and its oxygen, which, as you guys know, nitrogens only like to make 3 bonds, so there's obviously an imbalance in the charges here. And also sulfate. So if you guys look at these 2 electrons here, they're being shared between the oxygen and the sulfate. This means that this is a covalent bond, but all the charges overall, which are imbalanced in this, end up being -2. So guys, positive polyatomic ions form when the molecule is missing 1 electron, which means if you are 1 electron less, so for example, ammonium, you have lost 1 electron, you have 1 more proton than electrons, you're going to end up being a positive polyatomic ion, just like in any other case. But if you have extra electrons, meaning that you have more electrons than protons, you're going to be a negative polyatomic ion. So you see here, sulfate has 2 more electrons than protons in its overall compound. So another example of a polyatomic ion that you can find in your house is sodium bicarbonate. I'm sure if you went into your kitchen right now, this would probably be somewhere, right? Sodium bicarbonate is used for baking. It's also known as baking soda. So if you go here, this is the actual structure of a sodium bicarbonate molecule. So you can see here that there is a positively charged sodium ion and a negatively charged bicarbonate ion. So all of these are covalently bound to each other, but their overall charge is negative, and this is why they are bound to the sodium. The cool thing about sodium bicarbonate is that when you dissolve it in water, it can conduct electricity just like any other ion can. Remember yesterday we talked about how ions can conduct electricity when they're free to move through a liquid. So if you ever took sodium bicarbonate, dissolve it in water, and do the test, and electrical currents actually can run through that water because they're moving charged particles. All right, so monoatomic made up of 1, diatomic made up of 2, polyatomic made up of 3 or more. So now guys, that concludes this lesson. Go back, review the PowerPoints or watch the videos, whatever is easier for you. There is not going to be a worksheet today, so just ignore this and start the Google Forms quiz. All right, guys,